Problem 2b is asking us to graph each rational function and identify all of the given parts. With a problem like this, I typically like to start with my holes. Holes, if you remember, come from removable exclusions, factors that are on both top and bottom that can cancel out. In this case, there are none. Next, I would take a look at my vertical asymptotes. Vertical asymptotes are factors in the denominator that don't cancel out, and if set equal to 0 would make the function undefined. In this case, I would get x equals 4, -2, 8, and -5. So I can put those on my graph. Now that I have my vertical asymptotes, I can start looking at my zeros. Zeros are when the numerator is equal to 0. So looking at the factors in the numerator, I know that I would have a 0 at 0, 0, and -3, 0. So I can put those on my graph. I next need to find my horizontal asymptote. And that comes by comparing the degree of the numerator to the degree of the denominator. The numerator has a degree of 2, x squared. The denominator has a degree of 1, 2, 3 because of the squared, 4, 5. X squared is not divisible by x to the 5th, so y equals 0. We cannot do that division. Our quotient is 0. So I can put my horizontal asymptote at y equals 0. Starting from my right end, I'd like to sketch my graph, but I don't know if my graph is going to be above or below my x-axis. So one way I can figure that out is choosing a point and plugging it in. A nice safe point to plug in is 10. If I plug in 10 for x, I get 10 times 13 over 6 times 12 squared times 2 times 15, and I look at that and I say, oh boy, that's a lot of calculating, and I don't get to use a calculator. But what I do know is my numerator is positive and my denominator is positive, which means that my output is going to be positive and above the y, or the x-axis. That tells me that I'm going to be up here. So I don't need this piece down here. Coming in and taking a look at my vertical asymptotes and their multiplicity, I know that this vertical asymptote right here at x equals 8 has a multiplicity of 1. So if the right side points up, the left side needs to point down. And I don't have a root in this area, in this region of my graph between 4 and 8, that allows my graph to cross my horizontal asymptote. So once I reach that horizontal asymptote, I need to turn around and come back home. There's nothing magical to help me cross that. Then I look at my next asymptote, here at x equals 4, also with a multiplicity of 1. Given the fact that the right side of this asymptote is pointing down, the left side of this asymptote has to point up because it has to be opposite. In this case, I do have a 0 that allows me to cross my horizontal asymptote. Coming in and taking a look at my next asymptote at x equals -2, this has a multiplicity of 2 from the squared here on that factor. That means that if the right side points down, the left side also has to point down. And again, I have a 0 that allows me to cross the horizontal asymptote. And lastly, I want to look at my vertical asymptote at x equals -5, which has a multiplicity of 1. Again, this tells me that if my right side points up, my left side has to point down, and that helps me finish the graph right here.